Hey guys, welcome to the tutorial of Raspberry Pi 4. So if you haven't subscribed it, please subscribe. So before starting with the tutorial, like I wanna let you know like what is Raspberry Pi or what is IoT or what is Arduino. If you don't know, like if you know, you can skip to next tutorial and it will really help if you will just stay in this tutorial. So what is Raspberry Pi 4? So Raspberry Pi 4 is just a simple processor. Like you can see some normal motherboard. If you can like see it, it's a normal motherboard, nothing else. So what we do, we just code into it, like we just send our code, whether it's in Python or embedded C or C++. We just run our code in this and we can control different things. Like let me just show you an example. Suppose this is my laptop, like you can see. Okay, so this is my laptop. I have a motherboard inside it, so you know they have a motherboard inside it. And from that motherboard only, like we have controlling screen, keyboards and my mouse, everything. So the same thing is with the Raspberry Pi 4. Like we just add a light here or some sensor, so and we add a button here, so we'll just click the button and the light will all. So the same way in the laptop, like we press suppose enter, the screen light just get on, if like and the same thing, like we press the power button, the it will start running. The same thing is this also, but this is just in a small piece, like it's like for a small thing it can control, do only small thing, but this is for big thing. So the next question, there are different motherboards, like maybe hundreds and thousands of motherboards. So they, everything has their purpose, like, but Raspberry Pi 4 is basically very famous because it's easy to learn and it's made, basically made for do it yourself, like you can just do whatever you feel like, and it's easy to run, so that's why it's pretty famous. So see, this is my remote control. Okay, so this may be also having Raspberry Pi 4 or something, and any motherboard, I don't know which motherboard they are using, so they are also using any motherboard. So inside this we just told, like when you press, like when you press this key, the player, like the game player should move forward. So same way we'll just code here, and there should will be different sensors we'll just attach. I'll just let you know everything, where to buy Raspberry Pi 4 and where not to, and this is how you see. Let me just show you one more example. This is my mobile or smartphone. This also have a motherboard, so and we control it like our system with this only, like system I mean smartphone. So that's the way everything works. So sometimes the motherboard is really small, sometimes it's big. And this is Arduino is also like this, but it's less powerful, less, because it's made for different things, like small things, like maybe just controlling lights and all that stuff. But this is made for like big things, like you can control uh, face recognition, camera and different thing, multiple things. Now the next question comes, what is IoT? So IoT, just like this is a processor or motherboard, or basically you can take any motherboard like this, or there are hundreds and thousands of motherboards. So suppose this is a motherboard and we just connect it to the Wi-Fi, and it's like connected to the Wi-Fi, and whatever like suppose we attached a camera. So whenever we like what do I say, I have made an application in my Android phone. So whenever I click like capture photo, so it should capture a photo. This is what is IoT, that's Internet of Things. Like I can control it with my internet only. That's the only thing. Like suppose it has a bulb, so I'll just maybe I'm having an application, I'll just click on, so the bulb should on. I'll just let you know every encoding, then that'll be little simple for you. That's the thing. Okay, the next thing, what is Raspberry Pi 4? Like there are different version, like Pi 1, Pi 0, Pi 3, Pi 4. So like the iPhone 4, iPhone 5, iPhone 6, iPhone 7, iPhone 8, 9, 10, 11, 12. Now it's 12 also. So yeah, that's the way they are much more upgraded, and this is 4. So I'll just show you like where to buy and all that stuff, and the sensors also. So if you like the video, please like and subscribe. Thank you. Hey guys, welcome to second tutorial. Now in this tutorial, I'm gonna let you know like what are the components of Raspberry Pi, like which things do what purpose, or they serve what purpose. And I'm also gonna let you know like where you can buy Raspberry Pi 4, or you are, and all that like sensors and all that stuff where you can buy. And I won't confuse you, like buy this sensor, buy that sensor. I will just give you a link, or will tell you like how to buy a not just a normal kit, just paying like some bucks. So that'll be little easy. You don't have to choose it. Okay, so let me just start with the Raspberry Pi 4 introduction. So you can see these are the GPIO pins. Like
If we can see it perfectly, like these are the GPIO pins. These pins means like here we take input and output with the help of wires, like normal wires, we call it jumper wires. So here we take input and output, and this is the processor we have, like whatever processor, like every motherboard have a processor. This is the processor. This, I don't know, maybe I think this is RAM. I'm not sure of that. And this is like where you can fit your camera. So like if you want to like use Raspberry Pi 4 camera, so you can use that also. So this is the camera part. Okay. So now just come here. So you can see these are the USB ports. So this is USB 3. I don't know it's USB 3.1 or 3.2, but yeah, I'm sure it's USB 3. So these are the USB 3. So the transfer rate will be very fast. So it's got touched. And this is like USB 2. So if you want to connect your keyboard and mouse, you can connect here, and pen drive or and all the other stuff which you want a faster transfer rate, you can connect here. This is your Ethernet cable, like you can directly connect your Ethernet cable and like browse internet. This is your audio jack from where you can get audio output, and these two are micro HDMI connectors. Like you can connect your display also, and you can use it like a computer. You have to install Raspberry Pi. I will tell you every process in next tutorials. So these are micro HDMI. So make sure these are micro HDMI, not mini HDMI. So if you are going to connect it with external monitor, so you have to buy micro HDMI to a HDMI connector, not mini HDMI to HDMI. It's micro HDMI. Keep that in mind. And one thing more, sometimes when you connect with Wi-Fi, so what happened? It doesn't connect. So like in my case, I have seen and I have read some threads also online. That was one problem. So what happens? So sometimes if you have connected this port, so it won't work. Sometimes maybe 99% it won't happen with you. So if your Wi-Fi is not connected properly, so you can just switch to this port. So that will definitely help, or this port to this port. And this is like USB Type C board which gives power supply of like 5 volt 3 amperes. So and please buy a original charger of Raspberry Pi, so otherwise can like cost you much also, like it can get burned or like that stuff. So buy original chargers. And here is the like what do you call it, like slot for your micro SD card. Let me just show you. Like this is the micro HDMI card, micro SD, so sorry, HDMI. So micro SD card. So here you just put your micro SD card. It's like a hard disk. Like in laptop we have hard disk where we install our OS. In this we have micro SD card. SD card. Sorry, I just get confused. So yeah. So let me just tell you like where to buy and what stuff to buy. So in whatever country you are, just go there and type Raspberry Pi, and the first website will open. Just click it. You can click Pi 4. Let me write just Pi 4. Yeah. Buy a Raspberry 5 Pi 4 model. Go to the original website. Okay. So you just click here buy now. So please buy the 2 GB RAM variant. Like I have a 4 GB, but I just bought it and I was so frustrated why I bought so expensive, because your 4 GB RAM is huge. And even 2 GB, like 500 MB was enough. So please, I am requesting you buy a 2 GB RAM, and just select your country, like whether whichever country, like you are in Denmark, and it will just show you the website. So in Denmark it's available on this website or this website. So in whichever like country you are, just select that country, and these are registered, so you don't get like okay, I will buy from that website and it will like not come. So these are registered website. And as I am from India, I bought it like from factory forward. It was like 100 and 500 rupees cheap. So yeah, you can buy it from there. And other stuff, you can just go to Amazon. Like you also need like wires and jumper wires and all that sensors. So you just type Arduino kit. Okay, just press enter. So you can see the it's in the kit. You can have everything. See what, maybe this kit doesn't have one or two things that it's having, and maybe this not having this one or two items of this kit. So what happens, like if you don't See, the thing is, there are thousands of sensors. I just don't know how thousands of sensors. But the most common sensor, like they are used, like are about like 15 or 20 sensors. So like yeah, if the one sensor is not present in this, so it doesn't matter. Like I will teach you with the kit I am having. If that sensor isn't present in your box, so you just can skip to the other like other tutorial. It doesn't matter because there are thousands of sensors. So it's very difficult to get the matching sensor and the sensor and the kit I have bought. And let me just show you. I will give you the like website, like the link of that uh, kit also, so you can just buy it. Or you can check like what products they offer. See, I bought this Sun Robotics. Yeah, I bought Sun Robotics Arduino UNO based super starter kit. So you like if you wanna like buy it, you can just if it isn't present in your country this product, so you can just come down and check the accessories. They must listing the yeah, these are the accessories. You can just check are these are the accessories available in the box of the kit you are buying it or not. And please make sure one thing, your board should have like breadboard. So you can see it's breadboard written here. You can see it like on the this part. My mouse is like in the it's a white color breadboard written. Please make sure you have a breadboard and a big breadboard, like a bigger size. Let me just show you. It's showing you in the picture it looks small, but in reality it's very big. So make sure you have a big breadboard because breadboard is very important. And other stuff like jumper wires, like everyone have jumper wires and all that stuff. So yeah, so if you like the video, please like and subscribe. We'll meet in the next video about installation and all that stuff. So yeah, thank you.
Hey guys, in this video, I'm gonna let you know like how you can install Raspberry Pi OS in the memory card, because you only need this SD card or memory card. So it should be minimum of 16 GB because 8 GB won't work definitely. So it should be minimum of 16 GB, and it should be of class 10 or class A because the read write speed will be faster. Otherwise, it won't be like your Raspberry Pi will work slow. So it should be of class 10 or class A, and you just have to like you have to just insert it like this, okay, like this. Actually the OS is installed in this only because it doesn't have like Raspberry Pi doesn't have any like memory or that type of thing, and it doesn't boot up with the USB also, so you need like memory card to boot up the Raspberry Pi, and you have to install the Raspberry Pi OS in this only. So you need a card reader for that also. So you just plug the card reader in, like memory card is a card reader or whatever is the call. Okay, it's plugged in. Now I'll just plug it in computer. Now you have to download few things. Like first you have to download like Raspbian. Just type Raspbian OS, Raspbian OS, RASPBIAN. It will automatically detect, and just click download Raspberry Pi OS. So see, there are different versions of OS like Raspberry Pi OS desktop, Raspberry Pi OS with desktop, Raspberry Pi OS Lite, Debian Buster. Like there are different type of versions like distro, like in Linux, because these are Linux based. So just download the first one, Raspberry Pi OS with desktop and recommended software. Download the first one. Okay, it's of 2.5 GB, so I'm just canceling it because I have already downloaded. So it's a zip file. When you unzip it, it will be around like 6.8 GB or like 7 GB something. Next, you need a software called Balena ETCHF, Balena HS. Okay, just go to Flash, go to and just download Balena EHF. Okay, I have already downloaded. It's of like 125 MB. Just cancel it. So let me just go to download section. Okay, this is the like when you unzip the SDN OS, you will get sorry. This is like the exe file for the Balena HR. You just install it like the normal installation. So let me just delete it from here. You just have to normally install it. And for the zip file you have downloaded, you will get like sorry. So you will get a zip file like this. See, this is the zip file you will get from when you unzip that Raspbian OS. So move that zip file wherever it you have, just unzip it. Then open Balena Etcher. Then select flash from file. Then select the image of the SBN OS. Then click open. Then select target. Select the target of the your SD card. Don't select like your hard disk. Just check the size of the device. Then select one. Then flash, and it will take like around 5 to 10 minutes. Till then I'm just pausing it. After it's finished, so just go to your drive like a boot e name, then open it and then create a new file, text document, and name it SSH and without any extension. Please delete any extension like txt or whatever. Just simple SSH and just press enter and okay. Now it's been done and you can now plug it your device. Now we'll just go to the next tutorial.
So okay guys, like now your OS has been like updated or installed. So now just plug it out your like SD card. This is your SD card and like plug it in like here. Like this way is the upside and this is the down. Like if you can see, oh sorry, if you can see, this is the downside. Just plug it in. Yeah. Now I think now there are three ways to connect it to the what do you call display. Like if you don't have a display like LED or something else, so I'll just let you know like how you can do it with that also after like 5 to 10 minutes in this video only. But if you have a LEDs, then there is a three ways to connect to that LED. First is the first way is to that you should have like this micro HDMI to HDMI cable. This it look like this. So if what you can do, you can just plug like this micro HDMI cable here in this port. There are two ports for that, and this to the like your secondary TV or monitor, whatever you have. So you can just plug it in and make it on. And the second way is you can if you don't have a micro HDMI to HDMI converter or you don't want to buy, so you can have buy this like this is micro HDMI to HDMI converter. You can like just plug it in like this. Yeah, so this is like HDMI to HDMI connector. Maybe your TV, in home TV, you must have that connector, so you don't have to buy it. And third way is like if you have a like old monitor, very old, which support OTG cables like this, like OTGB cables are like this. So if you have a very old system, so you can buy like you can see HDMI to VGA, like it's called VGA cable, like HDMI to VGA cable. So what you can do, you can first plug it in like here. Oh yeah, then you can plug your this connector. These all are called connectors. Then you can connect it to like VGA cable also. So there are total like three ways in which you can connect it to the like display. So once you connect it to the display, and this is the charger, like just plug your charger like this and connect it to the whatever like power source or whatever. So like there are total three ways. So after you have connected, I'll just let you know what else to do. And one thing more, like if you don't have like any display and you are like how could I do, so I'll just let you know in the after a few minutes. So for those who have video, let's get started. So okay guys, after you like I have on the power source, so it will like on like this or maybe some other step will show off. So we'll just go next. Just select your country, like mine is India. Mm, yeah, language English. Yep, time zone code. Next, setting location. Please wait. It's doing something. Like if you have a Ethernet cable also you can just connect the Ethernet cable directly. So password. So normally put password RASP let it be leave it blank only. Then next, see if your display I have some problem, you can like check it. Then next, then here you can connect to the wireless network. So I have already connected. Next, if later. So I have already restarted and all. So after like you can come here and connect to the Wi-Fi whatever you want. So like after you are connected to the Wi-Fi or Ethernet cable, you have connected to the net. Just open the terminal and type sudo apt dash get update. See, if you don't have enough data, like you have only 1 or 2 GB, don't do this. Like it will require like about I think 6 to 10 GB, and it takes about an hour to complete. So if you have not enough GB, you can just skip it. If you have, so then you can go and then press enter. So it will just I have already done it, so it won't show anything. Otherwise, like it will like first you have to do sudo apt get update. Then you will do sudo apt dash get. Okay, now you have to type like sudo apt dash get upgrade. So like after update, you'll do upgrade. Like first you have to do sudo apt update, then sudo apt get upgrade. Now like it I have already done like it's still like 700 kbs left. So like it will take around like 1 to 2 hour, and you should have like plenty of GB. If you don't have, don't do it. Like it's like about updating your Windows. So but it's best to like update. So yeah, so like Python is already installed. Let me just clear the screen. Python 3. Here you can just like print, so you can write whole command here only. Hello, say hello. So you can write whole command is the terminal, like what you call command prompt. And like here is the what you call code editor. Just go to code editor and will be like new. Oh sorry, like you'll be first save it, control S. And like you want to save it where, like I will save in documents here only, and the Python name will be first dot py. Okay, now I like print sorry, print hello while just running. See, it's printing here. So if you wanna like code in directly into the what do you call Raspberry Pi, so you can do it directly. Just you just have to like plug here keyboard and mouse and the display, and you can just directly code here. And it's a Linux environment. So like this is the way you will do. Like these are all the files of different things. Like this is the like files system. So you want to go download, so whatever you want to do, you can just come here and do it. This is the browser, like you can click here, it's a Chromium browser. So what do you want to like watch or whatever you want to do, you can just come here and like google.com, like a small PC, you can see it, say it says like google.com raspberry pi. Yeah, so it's working perfectly. So yeah, so if you are in the next tutorial, I'm gonna tell you like if you don't have a uh, display, external display, or what do you call LED monitor or like that stuff. So there's another way also to like set up the Raspberry Pi. So in the next tutorial, I wanna tell you that only. So if you have, you can skip next tutorial, but you should like see it. So yeah, thanks for the video.
Okay guys, like if you don't have an external monitor, so there is also a way to connect to the Wi-Fi and set up your Raspberry Pi. So basically you need this RJ45 cable, or you can also call it Ethernet cable, Ethernet or whatever it is called. I'm sorry. So you just have to plug one end in the Raspberry Pi and another end into your like laptop or your CPU, whatever you are using. Uh, yeah. Okay, so it's plugged. So you just now you have to download one software called Putty. Putty. So download Putty. Download it here. No, no, no. Sorry, sorry. You have to like you can download Putty here. Just click here and choose your whatever you are have like Windows. You have to like 32-bit or 64-bit. Just click here and it will download, like it's of like 2.5 MB or like something of that only. Now once it's downloaded, just install it and just open Putty. Now here you have to write let me make it a little bigger. Okay, in the host name you have to write raspberry pi dot local. So I'm repeating it like again, like raspberry raspberry dot local, raspberry pi dot local, and it should be ssh only, and just open. Okay, like click open. So it will open a window and it will like it's a terminal, so it will ask you like what's the login as. So always remember, Raspberry Pi default ID and password is pi is the ID name and Raspberry Pi is the password. So I'm just typing pi as ID and the password is raspberry pi. See, it's already written here, raspberry pi. So this is the password, not the dot. Uh, So this is the password. Just press enter. Hmm, I think I have typed incorrectly. What? Raspberry. Oh, I'm sorry. Raspberry is the password, not pi. Only like raspberry, not the pi. Only raspberry, like raspberry. So your default password will be raspberry. Like if you connect or do something in like your Raspberry Pi, so if you ask for password, to always remember it's raspberry, and your ID will be p pi, only like pi. Okay. So now if you came here, now you have to do like sudo apt dash get. So no, no, before that you just type sudo pi rasp rasp dash config. So type sudo rasp dash config. Mhm. Okay guys, now I'm gonna tell you like how you can code in the Raspberry Pi. So for that you have to like download Putty. So if you have already downloaded, then it's not a problem. Just Google Putty and just come here and just click here and just install it, like whatever MSI bit you have, like Windows bit you have. After that you have installed it, you should be in a terminal. Like I have already told you like how you can come in the terminal. So like I have already told you, like if you are using in a screen, then there should be an icon of the terminal, or with the help of this ethernet cable also. I have told you like how to come to this like terminal. So type here if config. I'm considering like you already connected with the Wi-Fi on your Raspberry Pi. See, there is like uh there is this address inet w. So just you have to type if config, then come to wlan, or maybe something else written in your on your like system, maybe Wi-Fi or something like that. Like there should be wireless name type. So there is a address inet. So just copy that address
You can just copy it 192.168.31.19. So you can see it. It's 192.168.31.19. Like I have written here only this address. One thing more, your laptop or computer and your Raspberry Pi should be connected with the same Wi-Fi. If it isn't, then it won't work. So keep that in mind. It should be connected with the same Wi-Fi. Just note it down and just close the session. Okay. Now open Putty again. Now you can just disconnect your RJ45 cable if you are connected. Just disconnect it. Just like you can throw it here. Just copy this address and you're gonna use this as a only like for whole of like whole the tutorial and SSH and write it Raspberry Pi and save it. So for the connection in for future you just save it. So see it's Raspberry Pi and just click and open. So login as Pi as I already told you, like your default ID is Pi. Password should be Raspberry, Raspberry. Your default password is Raspberry. Like Pi is your ID and Raspberry is your password. So you are in the terminal. So now you can type whatever you want. Like you can go to Python 3 and just type print hello world. But yeah, like you can't code whole your script here. So there's a way of transferring files between like your Raspberry Pi and system. For that, just keep it down. You have to download a software called WinSCP. Just download it. Just come here and download. Like I have already downloaded. So just install it like a normal installer. So I've already done all that stuff. So I'm just canceling it. So just like the icon will look like the WinSCP. Just open it. So see what was your just click here new site. Let me delete this ID. Okay, just click on the new site. It should like open like this only if you are like a new user. Just copy this host name that I have told you to copy. Just paste it here and your username like it was Pi and your password will be raspberry and you click here save for the future saving option, save password. Okay, and just log in. Yes. So see, this is your desktop, like my computer. So this is my desktop. Like these, see, you can see this is a QCI folder, torrent, Balina HR. So these are my like apps, and this is my Raspberry Pi. What do you call a database or what do you like a memory card or whatever like storage. This is my Raspberry Pi storage. So I can like easily shift things from here to here. Suppose I went to QCRI, so I can just pick anything and just transfer it here. Like I can just do like sorry, I can just like this and it will copy. Okay. So see it has been copied here. Now I can just bring it back here also. I will just do cancel. So like yeah, so you can make a new folder. How to make a new folder? Let me just see. Yeah, new folder directory. Name it like Python and just copy your all of your code here only. Just go here. Yeah. So no, you got my idea. What you have to do? You have to write script here, and you have to just copy it here and just run it from the what do you call this terminal. Okay. So let me just show you a demo. So what we'll be doing it. Let me just make a new. Uh, uh, Here is my Sublime text. Yeah. Yeah. Let me just open my Sublime text. So let me save it. I'll say first program 5. first program.py. Just save it. Sorry, I'll just save on the desktop. Yeah, save it. Let me just close it. No, no. Yeah. So let me just like print. Hello, hello world, and d equals to 4, a equals to 5, c equals to a plus d. I'm just showing you like how this thing works. Print c. Well, so yeah, it will like print 9, then hello. Before that, hello, just save it and just keep it down. So now open your WinSCP. So now just like you can refresh it. See, there's a file called first program.py. Now I'll just copy it in the Python folder. So it's asking me, I say okay. So it has been copied. Now I'll go to my this terminal. Let me just clear it. Quit it. So no, clear it. Yeah. So like how you run normal your Python program from the command prompt. Like this is a command prompt like of the Windows you can say. So you will say Python 3. So before that you have to like go to this directory. Uh, Python. Okay. So for that I will see where I am. ls no home py. So I'll do cd Python. Okay, it's capital letters. Python. Okay, I'm in the Python. So I'll do ls also see all the files. See it's showing me I have a file this. So I'll just run it like Python. Keep that in mind. You have to write Python 3 because it also have Python 2. So if you just write Python, so it will run the Python 2, not Python 3. So you have to specifically write Python 3. Then the first program.py and press enter. See hello world and 9 whatever I have typed in that program. Now if you want to like install some library, so you do pip3 install like flags suppose. So it just install it. Yeah. So yeah, I have already installed. Yeah. So that's the whole stuff like how you will do the like programming in the Raspberry Pi. So we'll meet in the next tutorial where we'll let you know how to control the LEDs. So for the time, thank you and please subscribe my channel. So, okay guys, in this tutorial, we're gonna learn like how to control GPIO pins or what you call general purpose input output pins, and we'll control LED with the help of that. So in this tutorial, we'll need two jumper wires like you must have in that kit like these types of jumper wire, and you'll need like female to male to female. See, one side is like you can see one side doesn't have pin and one side have pin, so you need male to female or you can say female to male whatever, and you don't need pin both the sides, so you need one female to male. Then secondly you need breadboard, so I'll know what is the use of breadboard and how to use it. And you also need one LED, you can see LED, sorry, you can see this now. So you need one LED also. So let's just, so see, these are the pins. These are the 40 pins. You can see these are the 40 pins. You can see it. So these are mentioned here. You can see 1, 2, 3, 4, 5. These are the 40 pins. See, the number one pin is this, like the number, the left hand side of pin. Like if you can see it, this is the number one pin. So you know these are 40 pins. Like 20 this side and 20 this side, you can see numbering has been done. So they are something written on this pins, so you need to understand what is that. So on the first pin you can see it's written 3 voltage 3 power, like it will continuously flow 3 power of 3 voltage, like you know voltage like 20 volt, 10 volt, so it will continuously flow 3 voltage. And this this is written 5 power 5 power. So this is continuously flow 5 power volt. And you can see this is ground. Ground means, plus and minus, or positive and negative side. So I feel like let me see. I'm having any. mm, yeah, supposedly. Okay, I'll let you. Okay, I have a charger. Let me just show you. See, this is my charger. So this is positive, like a 5 volt. You can say like it's in real it's more. So you can say this is 5 volt, and the second part is ground. This is ground. So one point like this is plus. You enter in the voltage part, whichever voltage you need, and the second part you need to enter in the ground part, like the ground. So like current will come from this way and will go flow from the that way. So now other pins like GPI2, SDA, SSC, GPC, LQ. I don't know what's the use of that, because maybe advanced, and TXD, RXD, PC, maybe something. Now this is again ground. You can switch here and switch. And now you can see this is GPIO 23. It's nothing written here. GPIO 24, 25, 17, 27, 22, and ground GPIO 6. So these are the GPIOs like you can control. Like you say, okay, I want these are all of 5 voltage. Okay, so you say, okay, I need 5 voltage output here, so it will just give you 5 volt voltage output. Then you say, okay, I don't need, so it will just end it. But in these two, like 5 volt, 5 volt, 3 voltage, and this is 3 voltage, so it will just continuously flow. Like I'll just show you, like you don't have to do anything, it will just keep on flowing. So that's the difference between these GPI 23, 24, 27, 22, 17. Like this will you will tell them like, okay, I need the flow, then you will say, okay, stop, I don't need the flow. So that's the difference. So you can pin like use any GPIO 6, 5, 22, 27, 17, 23, 24, 25, then 16 and 26, and these are the grounds. Ground leads like the minus point, like where you enter the second part. Okay, so this is the basics of GPIO. But suppose this is the LED. I want to turn it the LED, but like you can see, how will you fit that LED here? That's the main problem. So that's why we need breadboard. So let me show you how a breadboard works. See, you can see the design of breadboard. Let me just show you. Yeah, you can see the design of breadboard. See, these see on my screen. These are connected together. Like you can see these things, like this line, one line till half, where the color coding is like end. These are connected together. Okay. See, you can see the, like if you pin any current here, so the current will flow. You just copy, see my mouse. If you pin any current here, it will flow from here to here. Okay, these are connected like this. And if you like pin here, like after the half part, then it will flow from here to here. And for this, in this, like if you, these are like in this way, like if you put current here, it will flow from here to here. Okay, and you can see wherever, like it will put current here, it will flow from here to here. And if you put here, it will flow like this. And if you here, it will flow like this. The same way it's here also, this and this and this. Okay, you can see, like, see my mouse, so it will like flow here to here, here to here, and this way. Like you can see the I have the color is already mentioned, like the copy, the see, these are the same color, these like are in the same range of color. These are the same, and these are colored like this. So these are column wise and these are row wise. See, row have like same, like if you pass the current, it will flow all over it. And these are the column rows. Okay, column wise. So that's the difference of like how the breadboard works. Okay, now see, you can, like, this is the LED. Like if you can like see whatever LED you are having, there are two joints like this and this. So one joint is bigger and another joint is small. So the bigger joint will get the 5 volt or 3 volt input, and the small joint will have the ground. Like you will connect 5 volt with the like you can see you will connect the like longer leg with the, you can see there is 5 volt, 5 volt or 3 volt, and the smaller leg with the, this is the ground, this is the ground, or any ground. Okay, like in this you'll connect this with the 5 voltage or 3 voltage or any GPIO pins which are not ground, and the smaller leg with the ground pins. Okay, that's how will the this LED thing will work. Okay. Okay guys, this is the diagram I have made to explain you like how will the LED connect to the Raspberry Pi, and sorry for the design. See, you can see, let me just write one more thing. Okay, yeah. You can see this is the LED, like if you can see it clearly, like this is the LED, and this is the short leg. You can see this is short leg. This will go to the ground pin, and you can see here the ground pin are like this is the ground pin. See in my computer screen, this is the ground pin, this is the ground pin, like the number 5 is the ground pin, the number 9 is the ground pin. So this short leg will touch the ground pin, and the longer leg will touch the voltage pin. See, voltage pin are number 1, number 2, number 4. So the you can take the snapshot of the like diagram, or you can just google it also. And then GPIO 1727, this will go like current will flow from here, and it will just come here and will go to the ground. Okay, this is the plus positive side, plus this is the negative side, minus. Okay, so this is clear. Now there is one problem with the diagram, not with the diagram, like with the passing the voltage, like this is the LED, it can't handle like about 5 voltage. Like 5 voltage is too much for it, it will just burst down, not burst down, it will just slowly like burst, like simply like it only needs like 2 or 3 voltage, I think. So for that we use to reduce the voltage, we use like this is called you must have this in your kit. Let me just show you this. You can see it, like this is what is called, I just forgot name, resistor. Yeah, resistor. So you must have a resistor in your box. So there are multiple kinds of resistor, like 220 ohm and 1k ohm, 1000 ohm. Like you must have written on your box. So just you must have a resistor. So what will resistor do? Let me just show you. So this is the formula for voltage. If you add a resistor to the connection, so voltage equals to current into resistance, then the voltage will drop, because current voltage increase when the flow of current increases. So resistor will stop the flow of current, then your voltage will be decreases. But how will you fit this in this diagram? That's the main thing. So I'm just showing you like another diagram of fitting it. Okay guys, this is a diagram. You can see, then your 5 voltage 3 voltage come. Oh, I haven't mentioned this. Your 5 volt or 3 volt come, then there will be a resistor in between, like this is the resistor will be in between. Yeah, this is the resistor will be in between, then this connection will go to the long leg, then the shorter leg like the ground. Like the same thing is with the same diagram, like 5 volt same diagram, but here you having a one more resistor without before reaching to the longer leg, you will have a resistor. So I think the diagram is pretty clear and everything is pretty clear to you. And one more thing, I'm just gonna let you know, uh, you have to fit this diagram in the real world with the help of breadboard. Where's my breadboard? Lost. Okay, guys. Now I'll just let you know how to do the connection and all that stuff. See, the screen is pretty big, so take the longer leg and put it like in this part, and the smaller leg on this line. Okay. Yeah. Yeah, like you can see, it's pretty big screen. The longer leg, this is the longer leg, is on the this line in this part, and the smaller leg on this part. Okay. Now now the current will flow like on this line, like the diagram I have shown you. See, the current will flow like here on this column, and it will flow like here in this row, like the first row. Okay. If you can see the diagram clearly. Now we need a register also to install. Where is my register? So this is my register. So I will just put it before uh yeah. So I will put it here. Hmm. See, sometimes the hole are pretty tight, so you can just like press it and make it small, like easily accessible. Yeah, yeah. So I'll just plug. Yeah. So you can see the design. I think uh, the resistor one end on this line and the second on the another line. So now, what with the help of the diagram, we'll just pass the volt 5 volt current here and the ground pin here. Okay. So this is our Raspberry Pi. You can see it. Let me just see whether it's clearly coming or not. So see, I'm plug it in the ground pin. See, ground pin is the pin like number 6. You can see number 6. And don't these are not the pin numbers. Pin numbers are this 2017, 27, 22. These are the pin numbers. I'm telling the inside number. So this is the sixth number, sixth number ground. So just come to the third of the pin, like one, two, three. Third pin from here, and just plug one end onto the third part. One, two, three. Now this should go to the ground. So where our ground is, like the smaller leg is this. So we'll just plug it here because the current will flow all over it. Okay. The current is flowing from here to here. You can see it. So I was told. So it's coming here. Now we need to pass the current. So we'll just take the 3 voltage, like the number one, you can see it. 3 voltage, 3 ampere, maybe ampere, I don't know. I'm just, and the current will just send it here. See, the light is glowing. So I'm just again telling you the current is coming from here 5 volt, then it's going like the resistor is on the same line, then the flowing from the resistor decreasing the voltage and going to the larger leg of the LED. Then from the smaller leg we are taking the voltage back to the ground. Now see, like if I put the like into the 5 volt, the 5 volt is the number 2, so the light will increase. See, is the intensity of the light has increased. You can't see because like on the camera, but yeah, I can see intensity is increased because I'm passing 5 volt. Now back to you, showing you the 3 volt. Okay, see, it's little bit dim. So see, this is 17, 27, 22. Like if I'll plug it, it won't happen anything because I haven't coded. These pins are for coding. Like if I'll code, then they'll work. So basically, yeah. So these pins, if I'll code, then only these pins will work. So we'll show you after. I'll just do the in the next part. I'll just show you the coding and all that stuff. So for the time, I think it's clear. Okay, guys, let me show you again, like with the little bit tilt. So this is like the larger leg is plugged in here, and the smaller leg here. You can see. Then this is the voltage. Where is my? So this is the resistor. So I plug this part in the line of the larger leg and the other part in the other end. Yeah, you can clearly see like larger leg have like one part of the resistor in the range of the larger leg and second part on this line, and the volt ground part I'll just plug it on here like on this line, and the larger part I'll just plug it on the voltage part I'll just plug on the line of like resistor. Okay, see this, I think you can see it clearly now. Okay, so that was all stuff. So in the next part I'll let you know how to code it and control it with your Python programs. Hey guys, in this video tutorial, I'm gonna let you know like how you can control LED with the help of Python, like programming and controlling the LED on the Raspberry Pi 4. So let's just start with the connection. You can see like I have connected the LED like this in the breadboard. Now I'll just take one wire and put it on the ground. The ground is like you can see the third sixth number on the sixth. that is 1 2 3. This is the sixth one, ground, and this is the shorter leg. Where's my pen? Yeah, this is the shorter leg. I'll just put in on the shorter leg. You can see my diagram, I think. Oh, sorry, display design. Then another, this is the 5 voltage. No, before that I need to use like resistor. So I'll just plug the resistor here. You can clearly see. So I'll just do like this. So you can see the resistor also. Now I'll just plug one in one of the voltage, like 5 voltage. Yeah, the corner one, and just plug this into the here. So you can see like how the connection, like I have told you in the previous video about the connection also. So yeah, this is the way of doing the connection, and this is for the Raspberry Pi. If you can like see, this is for the Raspberry Pi. Okay, so these are the connections. So let's just start with the coding part. So I'm just opening my Sublime text. So I'll say from GPIO 0 import LED, and now I'll say I'm importing LED from GPI 0, then I say LED small LED comma bracket 17. So here I'm telling like I want to use the LED 17 GPIO pin. See, let me show you the diagram. This is the 17. You can see this is the 17 GPIO 17th pin. Don't go with these numbers. Go with this number. This is the GPIO 17. So I'm saying I want to use GPIO pin 17. So I'm saying GPIO 17. Then I say LED dot, I'll pass a function call on, and I'll just close the bracket, and I'll just save it on the desktop only. Uh, mm, LED, no, no. Mm, what should I save it? Like pi LED dot pi. Okay, on the desktop, like I've saved it. So let's just close, and now I have to send it to the Raspberry Pi 4. So for that, I'll use WinSCP. I've told you before also. So I'll just log in here. I have already mentioned like Pi is the username and Raspberry is the password. And this is here like your the one I have told you like to log in the way, and it's logging in. Okay, it's now logged in. So I'll go to Python. So I'll just copy it here like okay. So it's being copied. So now I have to run it. So for that, I'll go to Putty and I'll say Raspberry Pi open login as Pi password Raspberry. Okay, I'm here. So I'll just go to cd Python because all my files are in Python. Sorry, it's capital. Yeah. So now let me just clear the screen. Now I'll do ls. So you can see like this is the file first program.py and pyled.py. So let's just plug this 5 voltage. No, let me just see. 17 is the number 11. So 1 2 3 4 5 6. So from the left hand side, the sixth pin, I have to plug in the voltage. If you can like see, let me just, yeah, I have to plug in on the sixth one, like 1 2 3 4 5 6. Let me just count it. 1 2 3 4 5. Yeah, sixth one. I have to plug in sixth one. So you can see that, but it's not on because I've told you wherever 5 volt is written, the power is being supplied, and where only GPIO is written, so the power is not being supplied. So I have to control it. So I'll just run the Python program Python 3 pi led.py. Okay, it's not getting on. So can anybody tell me why it's not being on? It's actually like let me tell you, the program is running so fast, like it's just on off, like it's like on off, on off. So you eyes can't see it, just on off, and your program just end. Like you can let me open the program. So where's the program? Uh, yeah, yeah. So let's open it. So it's like it's importing, it's setting, and it's letting on, and the program ends because I haven't said okay, let the LED be on. Just the Python program, and it's just like and it's like just getting off. So what I'll do, I'll say I'll so how what should I do to make it LED dot on running? Like it should run and run and run. It doesn't end the program. So I will like introduce a while loop. So I'll say while true. Now I'll just save it. So you can edit it directly from here also. Like after the you have like copied file. Now if I run it, same thing. So it's on. So that's the way, because the program is not ending. Now as soon as just I end the program, see, it's not. Again I run it, and again it will work. So that's the whole setup of LED. Now if you want to make it off, this is also a tricky one. Let me off the here. Okay. So if you want to make it off, so you will do LED dot off, and you save it, and it will in the while loop it will like on off on off on off. Okay. So just run the program again. See, it's on off, but now you say, oh, okay, it's not like it's not switching off. It's just on a on state. It's switching off, but our eyes can't see. It's like this only, on off on off on off on off on off on off on off. So our eyes can't determine whether it's on or whether it's off or not. It's just on, looks like on the on state, but in real it's on off on off on off. But in real it's on off. But as I see, it's like on, like single click. So what we'll do here, okay, so first just end the program, I should say. Yeah, clear it the screen. Yeah. So we'll say, so we'll say we'll import time. So we'll give it some time. From time import sleep. So here what we'll do on, then we'll say sleep, then we'll make it sleep for 1 second. So for once we are making it sleep because on, then it will sleep for 1 second, then we'll say sleep, and we'll say 1 second. Okay, so it should work like on, it will on, then it will sleep on the on state, then it will off, then on the off state for 1 second, and we'll save it. Now we'll again run that the program. See, now it's like showing us okay, on, off, on, off, on, off, on, off. So let me just end the program and show you some more things. So what else can we do? We can make it like little bit faster. We'll say 0.5, and it's also 0.5. Save it, and we'll just run it. It's little bit faster. I feel as the number will keep making it small, and it will work faster and faster. So let me just make it 0.2, or maybe 1, 0.1, and just save it, and now end the whole program. Now again run it. See, it's very fast. You can see it like it's on off on off on off. We can see like it's very fast, but we have to introduce sleep. Okay, so let's do some other stuff of coding. So we want to make something like looks for real, we'll say. LED dot on 0.1, LED dot 0 point sleep, and if you say LED dot on, make it 5. I wanna look it like very much classy. You'll see what I'm saying. LED dot off, then LED dot on, then again sleep 0.5, then LED dot off, then sleep 2 seconds. So it's like on, off, then off for 2 seconds. Like it's like tick, 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 tick. Like it's a design pattern, like kind of design, not really a design, but yeah, it looks cool. We'll just close this program and again run it. Off, then again on, off, on, off, off, on, off, on, off, off, on, off, on, off, on, off. So in this we can print also whenever LED is on or LED is off. So we'll say print LED is on, and we'll say sleep 2 seconds. Then we'll say LED of off and we'll say sleep 2 seconds, and we'll let delete these things. Yeah, so after LED dot off, like we'll say print LED is off, and we'll save it, and now we'll just run it. So you will see it will print also for every time it will on or off. Okay, LED is on. You can see my LED is off, now it's showing off. Then LED is on, LED, like it's running like this only. It's just normal program. You can see it. There's nothing much. On, off, on, off. So yeah, this was like the for the LED. In next tutorial, we'll learn how to control buttons. Then we'll learn controlling buttons. So week after that, we can use like controlling our LED also. So yeah, that's it for this tutorial. If you liking it, please subscribe it. So okay guys, in this tutorial, I'm gonna let you know like how you can control button with the help of Raspberry Pi 4 and Python. So this is the button. You can see, if you can, like, this is a normal button, just press and it will be get released automatic. If you like release it, just a normal button. If you have bought the same kit as I have bought, so it should be in this packet button. Okay, so this is the normal button. I'm let you showing you again. These have 4 legs. Okay, normal button. And apart from that, you need two jumper wires. One is male to female, like one has pin, another one don't. And the second one has male to male, like two pins, like male to male two pins. One resistor, like you can have of any ohm, like I'm using of 200 ohm, you can have like 300 ohm, but always use resistor because your something can get burst, or like what, like it just drops your voltage, so it's best to use resistors. So, and this is the connection from the previous video, and please let the connection be secure like this only, because I'm gonna let you know how to control like LED with the help of button. So before that, so let's just make the connection for the button. So just uh, these have 4 legs, just put it anywhere on your side. Yeah, so it's like very tight now. Okay, you can see it, this is the button. Now what I'll do, I'll just take a female to male LED and put in the GPIO2. You can see the pin GPIO2. It's number 3 from in the middle. GPIO2. You can put in any GPIO, like GPIO 3, 17, 27. You can put it anywhere. Okay, wherever GPIO is written. So we'll just put in the GPIO2, and we'll then I'll just put it here. Okay, yeah. Okay, so I am putting it here. Now we'll need a resistor because the voltage will be like very high. So I'm giving on the one leg, I'll just putting it very hard. Let me just make it a little lighter. Okay, so you see, you can put it like on this other side also or this side also. Other side where I can you can put it here also or here, but here no space is there. So basically, I'm just putting it here. So what's happening? The current coming from the GPIO pin 2 and is coming here and going with the help of resistor. The voltage is getting down and just coming into the bulb. Now the second part, I told you the second part should always be in the ground, but one problem is there, like you already are having a ground pin here, you can see, for the LED. So you can just connect to that LED ground only. For that, for other material you don't need separate ground. You can just come here on this, you can just come here on the other part of the button, that plug it. You can just plug it in the pin of the ground also. Like you can see there is a 9 numbered ground, you can put it there also. But why, like when you are having the ground in the board only, so this is the ground pin, the yellow pin. So I'm just putting in the same line of the ground pin. Okay, see, the connection has been done. So it's maybe it's little bit what do you say, confusing, but yeah, that's how it is. So let's just start with the coding part. Okay, so I'll say from GPIO 0 import button equals to button. So can you tell me which pin number I'm using for the button? Okay, let me just show you the image. Okay, I'm using the pin number 2, GPIO 2. So I'll just write 2 here. Okay, and I'll say the same thing while true will write if button is underscore pressed. I'll say print button is pressed, else print button is released. Okay, let's make it sleep for 1 second, otherwise it will go very fast. Yeah, so this is the command, just save it. As I told you, I am just editing the same thing, like I'm just editing this only, like uh, opening it and just editing it. Just save it. I'm just going to run it. Python 3 PyLED invalid syntax. I think there isn't brackets. Okay, let's just run it. What? Okay, sorry, I just said it's when not is WHEN when pressed. Print button is pressed. Now just save it, and I'll just what? Okay, I think the brackets. Okay, it should be is pressed only. I was not putting the, like, what do you call some colon, so that's the colon was the problem. I just, maybe sometimes, small mistakes make big difference. Yeah, let me just clear the screen. See, button is released, so it's printing. So what happening, it's coming and checking if button is pressed. So button is not pressed, so it's going to else and printing button is released, button is released. So whenever I'll press, see, when I'll press, see, button is pressed, is let me just, yeah, you can see now the button is pressed, button is pressed. Before it was button is released, now button is pressed. So as soon as I just release it, see, button is released, button is released, button is released. So the next thing is, like, how will I control the LED? Like, it's also is all it's the button is also called push down button. So yeah, so if you wanna know. The second part is, like, how will you control the LED? So for that, at least we need to import LED from Gpio 0 import LED. Okay, now we'll do LED equals to, okay, tell me on which GPIO pin LED is connected. The LED is connected on the GPIO 17 pin, so we'll light LED 17. Okay, so see, it's very easy. Whenever the button is pressed, so we'll just say make LED dot on. Okay, LED dot on. Otherwise, button is released, make the LED dot off. Now just save it, and I'll just show you how it will work. And the old program, clear the screen. Like, now you can see the program. I think the Raspberry Pi pics were coming. Okay, if, let me just tell you again, I'm making LED on the button, GPIO 17 button on the GPIO 2. So I'm saying if button is pressed, print button is pressed and make the LED on. Otherwise, print button is released and make the LED off. So let me just run it. See, button is released, button is, as soon as I just press the button, this see LED gets on. Button is pressed also and LED gets on. Okay, so button is pressed, LED, the button is pressed. Now I'll just release the LED got off and button is released. So yeah, that was all about it. So if anything gone wrong, so I'm so sorry for that. So if you like my video, please subscribe it. Hey guys, in this tutorial, I'm gonna let you know, like, how you can control the brightness of a LED with the help of Raspberry Pi. So if you haven't subscribed the channel, please subscribe it, and let's just start with the connection part. So firstly, I'll put this plus in the, like you can see, this is the GPIO 17, 11th number, GPIO 17. So I'll just plug one in the GPIO 17. 1, 2, 3, 4, 5, 6. Okay, sixth pin. 1, 2, 3, 4, 5, 6. Okay, I have plugged in the GPIO 17th pin, and I'll just put it here. Now current will flow from here to here. Now I'll need a resistor to, like, slow down the voltage, low down. So I usually use, like, 220 ohm resistor and 300 ohm. Like, your resistor should, like, near about 200 to 300. So yeah, so let's just plug the resistor. Okay, hole is very tight. Let me make it a bit deeper. Yeah, now it will fit correctly. Okay, now I'll just put the bigger leg of the LED here. Uh, yeah, okay. I have put this wire into pin 17, and it's coming from here, going from resistor to this line, and from this bigger leg to this line. You can see now I'll put the ground pin, like the third pin, like the one, two, three.
the number 6 or the third pin. I'll put the ground pin. I'll just put it here. Yeah, so now it's taking the ground from here to here, then here. So let's just start with the coding. So we'll say from GPIO 0 import PWM LED. Now from time import sleep. What sleep does, like, stops your program for a second. So like if you want, then we'll say LED equals to PWM LED, and our pin is, like, we have plugged in the pin 17, GPIO 17. So we'll write 17 and we'll say while true, LED dot value equal to 1. So in PWM LED, the maximum value is 1 and the minimum, like, basically it start from 0 0.0, 0.1 to 1, but yeah, you can, like, give it 0 or 0.001. So and the max value it is 1. So basically if you will give 1, the LED will like glow with the brightest, and the lesser amount of voltage value will results in dimmer glow. So let's just show you with the LED dot value 1, Python 3. See, the LED is glowing very good. Now just change it to 0.1. Now just save it. Now it's very dim. So okay, so now we'll just make it dim and low again and again. LED dot value equals to 0.13. So we can see the changes. 0.5, 1, sleep 0.5. So you'll say the LED will glow light and dim slowly. Yeah, see, it's going very dim, like it's going like high dim, high dim, high dim. So let me just make a list. LIST list equals to 0.1, comma 0.2, comma 0.3, comma 0.4, comma 0.5, comma 0.6, comma 0.7, comma 0.8, comma 0.9, comma 1. So I loop into this for, let me just delete it, for I in list LED dot value equals to I. So it will come 0.1 and will increase the LED values, like it will grow brighter. So let's just save it. It's like doing so fast we can't even, like, watch from my eyes like what's going on. So we'll just, like, make a sleep here. Sleep. Yeah. Now we'll again turn it. So you can see it's slowly glowing, 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 glowing. Then very dim, then glowing, 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 glowing. Then very dim, glowing, 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 glowing. Now it's again very dim.
So like this, you can like control LED values. So let me show you with one more LED. Like if you have two LEDs, so what you'll do, you'll like take one more jumper wire and where we close, pin it to GPIO pin 27 just after 17th. Put it in here just after pin 17th, and I like do this. And for this also one resistor. Yeah, I think the hole is very tight. I again have to like make it deeper. Yeah. Okay, now I will just now pin the LED. So no, longer leg towards the resistor, the smaller leg on the ground. Yeah. So you can see we have the same connection, and the ground we can for the LEDs we can have the same ground only, so we don't have to like plug in the other ground. So you can see also ground are so less. That's the only reason we can have the same ground for the same type of devices. So it's coming here and the ground is same. So now just make LED number is like 27. So we'll just make 27. Same thing. And let me just delete it. LED dot value equals to 1. LED dot value equals to 1. Okay. We'll just glow both of them at very high frequency. Oh, but what happened? The only one bulb is glowing. So what we did, like we did, she saved the 17 pin in the LED variable. Then we again overwritten it by 27th pin on the LED variable. So this is the 27th pin. So that's the problem. So we'll make it like LED 1. So here if we do this LED 1, we'll be like, okay. Then again we'll run it. See, now it's glowing all of them. Now let me just do something. 0.5, 1, 3, 0.5. We're just making it like dim, 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 dim. You'll know. See this glowing, this. No, that's what I'm doing. It's glowing. Like you can see the code and you can know what I'm doing. Like glowing one, then keeping other down. Okay, this. So one thing you have noticed, I think, see the code has become so much messy. I mean, like if you have 100, not 100, like about 5 edit pins, so the code will go longer. So to overcome that problem, we have a different solution. So let me just connect one more LED and show you how to control it just for one line of code. So I'll just make the same connection. Now I'll just plug now the new connection in the pin number 22 just after 27th. Okay, now the resistor time. Now plugging in the resistor. So now the resistor has been plugged. Now the LED, where is the LED? Yeah. Putting the longer leg, then the shorter leg. Okay, now it's done. So for that, let me just delete all of this. We'll say from GPIO 0 import LED board. Yeah, from time input sleep. So we'll say LEDs, LED board. So what are the pin numbers in which LEDs are connected? 17, 27, and 22. Yeah. So we'll say 17, comma 27, comma 22. Then we'll start the for while loop, while 2 LEDs dot on. So it will on the all LEDs at once. See? Now make it on off, LEDs dot off. See? But our eyes can't see like when it's switching off because it's very fast. So make it sleep. Yeah. Now just run it again. Let me just clear the screen. What? Oh, sorry. See, now it's looking so good. So we can control their, what do you call, PWM, like the voltage supplied. So we'll do PWM equals to 2, and here we'll do LEDs dot value, and we'll say for the 17th we want 0.1, and for this we want 0.5 on, and for the 22 we want 1, and we'll just save it. Oh, sorry. It will be equal to, I just forgot. Yeah. See, this one is the dimmest, like because I have supplied 0.1, and this one little brighter than that, it because I have supplied 0.5, and this is one because I have supplied the full potential. So let me just keep changing the value interchangeably, so it will just look nicer. Sleep, because we have to make them sleep also. Copy, paste, paste. Okay, and this will make it 1, then 0.1, then 0.5, and here we'll make it 0.1, 1, and 0.5, just changing the values. So you can see how they are like changing their like brightness level. You can easily see. That looks cool. So yeah, so if you like the video, please subscribe it and like it. Thank you. So okay guys, in this tutorial we're gonna learn like how to use distance sensor, or it is also called ultrasonic sensor. So let me just tell you like how it's work like before moving forward. So basically what happens, one of the port, like you can see there are two ports or whatever you call. So one of the port releases ultrasonic waves sound. So they are like above 20 kilohertz, so we just can't hear it. So it just goes like this, and whenever it gets in like any object comes in between that sound, so it gets reflects back. So and the other port like receives that sound back. So and it calculates the like what you call a time travel by this and this, so it can like calculate the distance. So what happens, let me again tell you, one of the port releases sound and it gets reflected whenever an object gets played in front of that. So other port release receives that sound, and after that calculate time from releasing to like receiving, and that's the distance between time. Like you have heard of the formula speed equals to distance upon time. That's the work it is being done here. So yeah, let's just get started with the like, coding part and the what electronic part. So let's just start with the connection. So let me just unplug it, all of it. Okay, it takes too much time to plug, and unplugging is so easy. Yeah. So you can see the connection here, like we have to do a connection like this only. So you can see there is a VCC, like you can see here there is a VCC written. So we will directly connect it to the 5 volt, like 5 volt is this, which like 5 volt which is continuously releasing 5 volt. This is the 5 volt. So we'll directly connect to the VCC, and the second one will connect it to the pin number. Let me count it: 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. Okay, so the second one will connect to the pin number 23, like you can see, like numbering it like this, so it will be the eighth one. And the GPIO pin 23, the second one, its name is like what its name is, trigger. Okay, trigger. Okay, trigger is the pin number 23, will connect it to the pin number 23. Then the next pin is echo pin. Okay, echo pin. So we'll connect the echo pin to this, then we'll connect it the register. Then after register, we'll connect it to the pin number 24. Okay. So from that register, we'll connect it to the ground, then the ground to the ground, like the ground. So like it may be a little bit confusing. Just follow this diagram and it'll be really easy. Like just copy the same diagram. Like that's be really easy. I know I'm also showing you like how to connect. So let me just plug the device first. We can see like I'm plugging the device. It's hard. Yeah. Yeah, you can see like the this is the VCC part. Like this part is the VCC, the end part, and this part is the echo part. Like this is the VCC, this is the echo. Let me just again tell you, this is the VCC and this is the echo. Like you know, like how? No. Let me just make it like other other way. Okay, now it's be easy for me to like plug the pins. So this is the VCC, like here is the VCC and here is the echo. So now you can do the connection also easily. So let's just start with the connection. So for the VCC, you can see VCC is going to 5 volts. We'll just take it and plug in the line of VCC and connect it to the 5 volt. Like this is the 5 volt continuously supply. Okay. The next trigger pin is directly going to the GPIO 23. This is the GPIO 23. So we'll just connect the trigger pin Okay, so GPI 23, 1, 2, 3, 4. Okay, it's the eighth one. 1, 2, 3, 6, 8, 4, 5, 6. Okay, it's the eighth one. Then the echo is first connected to the register. So let me just connect echo to the register. Plugging in the echo. And the last one is ground. Sorry, I was saying last one echo, but the last one is ground. Now plugging in the echo. Let me just bring the male to male wire. Yeah, this is the male to male wire. So you can see I have just plugged this into like from the echo to the other part of here, and here I'll connect to the register. Let me just connect it to the register. Okay, I connected to the register. Then that register part has gone to the pin number 24. You can see this is the pin after 23, this is 24. That register part has gone to the pin number 24. Let me just put to the pin number 23, then this is 24. Okay. Now after that there is one more register. Okay. Now one more register has been connected. Now this goes to the ground. Like this is the ground. Like the from below fourth. Like you can plug it here also. Like the first, third one ground. Just so yeah. So now everything has been done. So if you like got confused with the connection, so you can just comment or something like that. I'm really sorry for that. So yeah. So let's just get started with the coding part. Okay, so let's just start with the coding from GPIO 0 import distance sensor from time import sleep. Now we'll say sensor equals to distance sensor. So firstly we'll give the echo pin, like echo pin is 23. So echo pin is like 23. Mhm. Then we'll see the trigger pin, that is 24. Now we'll save it. No. I think 24. 24 is the echo pin. Then trigger pin is 23. Let me just check the connection. Mhm. Yeah, GPIO 24 is the echo pin. You can see echo pin is connected to 24 and trigger is connected to 23. So okay, so say while true print sensor, we want to know the distance. The distance into 100 because it will be really small value, so we're just making it 200, so it will be easy for humans to like, understand. Then we'll say sleep 0.5. Okay, now we'll just go here and run it. Okay, see, values are being printed. So highest value is 100, but something is here, so it's giving me like 19. So let me make it little bit upwards so we can go. Okay, see, the maximum distance is 100. It's showing you 100 because after 100 it doesn't show, so it's showing you maximum. So as soon as like I place my hand in front of the race, so see, it start decreasing. Okay, you can see it's decreasing. It's keep on decreasing as my hands are coming near. Okay, see, now very low. Now it's like very much low. Okay, now I'll just remove it's 100 again. So yeah, that's like you can do like this. So that's the whole story of distance sensor. Let me just show you again. Ah, okay, see how cool is that? So yeah, thank you. If you like the video, please subscribe it. So hello guys, in another tutorial. So in this tutorial I'm gonna let you know like how you can make a mini project with the help of distance sensor and some LEDs. So if you haven't watched how to make connection and code for distance sensor, you can just watch my previous video. So let me just tell you like how the connection will be. So this is the connection diagram. You can like pause and see and make a connection because I have already explained in the previous video. So let me just check if it's running fine or not. So I'll just say Python 3. Okay, it's giving me in outputs like 100. Let me just make my hands near. Okay, see the values are decreasing very fast as my making my hands closer to the object. Okay, so yeah, so it's working very well. So let me just end it. So this is the code for distance sensor. So let me just do something like if some I like if something comes below 100, so it just light up an LED. So we'll say distance. So we'll take distance. First we distance equal to this print distance. So we distance and we'll say if distance is less than 50, we'll say print. Let's just check this whether it's working fine or not. Okay, so see 100 coming now. As soon as I place my hand, you just make it a little bit shape. Yeah. The 100 values are coming. So as soon as I just put my hand there, so it's giving me like 22 value also and the alert also. Now I'm making my hands far, 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 far. So as I go above 50, it's just printing the number. So that was it. Now, if we want to like bright up the LED, if the distance is less than 30, we'll say if the distance is less than 30, we'll say from GPI import distance sensor and LED. The LED equals to LED 17. So we'll just plug the LED into the 17th pin. So let's just make the connection. 1, 2, 3, 4, 5, 6. Okay, it's the sixth pin. Okay, this is the connection. Now I'll just plug here, like pin out here. Now I'll need one resistor also, as you know, to cool down the voltage. Yeah. Now I'll just plug in the LED also. Yes. Now the what do you call? What is called? Yeah. Now for the ground also. So I'll put the ground on this pin. One, two, three, four. Fifth pin is the ground pin. Just before the 17th. This is the ground. Okay. Okay, now I've just plug on this line, so it will cover whole line, so I can just put as many LEDs as I want. So let's just run the same program and say if the distance is less than 30, LED dot on. Okay, I'll just save it and we'll now just make it upwards side. Okay, yeah. Okay, it's giving me 100. So as I put my hands near to the, so see as it will go below 30, it will just see LEDs is on. As I go below 30, LED just got on. As I go far, but it's not going off. See, so that's the way we have to do. Like if LED is less than 30, LED dot on, else LED dot off. I will just save it. Okay, now we'll just do the same thing. My hands are coming near. Okay, less than 30, LED is on. Now I'm going far. LED off. Now going near. Now going far. Near, far. So now we'll make a better project obviously. So we'll need like four more LEDs. Like this is only one. We'll need one, two, three, four, and four resistors. And just we'll gonna make connections. So and now the second LED we'll make it to the pin number 27. Yes. Yeah. Uh, this is after the 17th pin. Okay, yeah. Now it's the same connection as if we have done it for the previous LED. Oh, sorry. First the resistor. Very hard. So let me just. Yeah. So now the third LED. So I'm pausing it. Just no, I don't pause it. You can watch the pin number. So better. Like after 27, I'll put into 22. Now the resistor. Now the LED. And now the LED. Oh, it's very tight. Let me make the hole. Yeah. So now we'll pin it to like 5 and 6. That is the 1, 2, 3, 1, 2, 3, 4, 5, 6. Sixth pin from last. Yeah. Put it here. And one more jumper wire I need. Yeah. Just after that. Yeah. Now now the resistor time. Now for that also resistor. Now the LEDs. The, now we are next to completion. Okay, we have completed. Now let's just go to the coding part. We'll do this. Now we'll say now we have used 27, 22, 5 and 6 in numbers. So we'll say 27, 17, 27, 27, 22, then 5. Okay, 5, 6, 17. Okay, it's in the same like range. Make it in range, not like this, like 5. Uh, First, make in the range the way they are assigned here. Okay. Okay, so these are the things. So we'll say if the distance is less than 30, less than 50, LED dot on. So first LED will get on. Now we'll say L if uh, and we'll say if distance less than 40, LED 1 dot on. Now we'll just repeat the same thing. Okay, if distance less than 10, LED 4 dot on. Here we'll say LED 3, distance will be 20, LED 2, distance will be 30, LED 1, this time will be 50, 40. So as soon as we'll go decreasing, the LED will be brightened up, and in the else part we'll do, no, not else, for that, for like else. Okay, let's just run it and see how it's working. So we'll see in the next part. So make it little bit upwards. So yeah, okay, distance is this. Now as soon as I going closer to like 50, 38, 37, but it's not okay. Yeah, see all the bright uh, LEDs are up, but I think some connection is not made properly. That why the problem is. Yeah. So now what we have to do, like if we remove ham, it should get off automatically. So for that, we'll make a else condition is every if else LED dot off. Okay. Now I will just do this. So everywhere we made else LED off because like uh otherwise it will just get off. So let's just again run it. Yeah, it's working. Now we'll just moving hands. Okay, some are not going off. So let's just see the coding. Okay, we have to do LED 1, LED 2, LED 3, LED 4. Now I'll just will run it. Okay, now we'll just move hands. 30, 28. Okay, as soon as we are going closer, the LED is getting on. As soon we going off, so LEDs are getting off. Let me just see one more thing why this connection is not working. Let me use another LED here. I think this LED is little bit dimmer or what. Yeah, now this LED is perfectly fine. The color is different. So, yeah. So one thing we wanna do, like, let me just show you one more thing. So if the distance is less than 10, 20, suppose, if the distance is less than 20, we wanna do LED 1 dot LED dot on, LED 1 dot on. Now just we'll copy the same thing. We'll make it 4, 3, 2, 1, and here we'll say sleep and copy the whole thing, paste it, and here we'll say off. So yeah, this is one thing. So it will look very good. So let me just show you as soon as I come below 20. See? So alert, 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 like that kind of stuff. So yeah, so this was from my side. If you like the video, please like and subscribe it. Thank you. Hey guys, in this tutorial we gonna learn like how to use buzzer. Buzzer basically means a sound system like where it will like do buzz type of sound. So this buzzer look like this if you can see it clearly, or you can see like this. This is the shape of the buzzer, and it has 2 points for joining, like one for plus and one for minus. Uh, there is an option also of plus on the above side, like where will be the positive side, where will the voltage come, and the smaller is the for the ground. Like the connection is same for the LED. Like we in LED we also have the bigger leg for the voltage side. Here also the bigger leg is for the voltage side, and the smaller leg is for the ground. And so we'll just start the connection, and we'll connect the larger leg with the pin number 17. You can see GPIO 17. It's the 11th number, GPI 17, and ground here like the third part. We'll do the ground connection. Okay, so firstly let's just uh, put this. This is the longer leg, you can see. Before that, let me just put a resistor. We'll use a resistor of 220. We'll use a resistor of 220 ohm, like you can use of any. Yeah. Okay, resistor has been plugged in. Now the longer leg will be in the line of the resistor. This is the my longer leg, and it will be here. Now the smaller leg will be connected to the ground. So let me just. Okay, the smaller leg has been connected to the ground. Now the bigger leg, like the uh, resistor, will be connected to the pin number 17, GPIO 17. It's the sixth frame from this side, like 1, 2, 3, 4, 5, 6, like GPIO 17. You can see 1, 2, 3, 4, 5, 6. So let's just start with the coding part. We will say from GPIO 0 import buzzer. What's the name of the, and we'll say like the in the LED we do like buzz equals to buzzer, and the number is 17th, and we'll do bz dot on. Okay, so it will make a sound. So let's just run it. Python 3. Okay, it's not making sound. Actually it did, but it ended so fast so we couldn't recognize. So we'll say while true. Now we'll do. Okay, it's making sound, but actually this mic is very like far, so you can't just hear it, but in your buzzer you can hear it clearly. So for like we'll do this, and for turning it off we'll do bz dot off. So it will go on off on off on off. But as in the LED it will be so fast that we couldn't recognize like how when it's turning on or off. So we'll say from time import sleep, and we'll say sleep 0.5, sleep 0.5. Okay. Now it's going like this. Now I'm making my mic near to the like sound system. Let me just do it. Now you will hear it very clearly. Okay, if you can hear like I have a sound distraction software, so it may have like vanished. Otherwise, you may have heard it. So that was this for the video. If you liked it, please subscribe.
So okay guys, today I'm gonna let you know like how you can control a servo motor with the help of Raspberry Pi 4 or any Raspberry Pi. So basically what you will be needing like obviously a servo motor. Mine is MG995. You can have it of any brand, or mine is Tower Pro. So you can, if you can see my brand and model number, if it focuses, it's not focusing. Okay, mine is Tower Pro MG995 and a Raspberry Pi 4, obviously a breadboard for connections, a resistor for safeguarding your like a Raspberry Pi is not really necessary, but I will suggest you to have one, and it's of 220 ohm. You can use of any, like, and few jumper wires, male to female and male to male, basically you will see, and a battery. Like you can connect servo motor directly with the Raspberry Pi, but I will suggest you to connect it with the external power source, because sometimes like a servo motor uh, like asks for more voltage, and it asks with the Raspberry Pi if you connect it, so your Raspberry Pi can burn or burst. So to safeguard your Raspberry Pi, I will suggest you to have a battery. Mine is like 9 volt. You can have it like, you can use it with like a pencil cells. There are pencil cells, you can like buy 4 pencil cells and combine them, 4 pencil cells, and make them like this, positive and negative, and I'll show you the like how you'll be making the connections and all. So yeah, okay, let me show you the connection part. Like if you already know, you can skip, but yeah, for others, so like in your motor you must have 3 wires like this, or of any color. The mid In mine, the middle one is your red wire is like positive side, the green or gray color, whatever, it's my negative side. Like if it can focus better, yeah, now it's focusing great. This is my positive middle red wire, this is negative, and this is yellow wire. Basically yellow wire is control wire, which will be connected directly to my Raspberry Pi, and this is neutral or ground wire, or this is red wire or positive side. Now what I'll do, I'll take this, like this is 2 wire, like this wire is mine positive side, and this is my negative, or you can say neutral. Now in breadboard, what I'll do, I'll pin the positive side in positive, see positive line in positive, like whether plus sign is being made, and then negative in the negative side. Okay, like this is my for now. Okay, now what I'll do, I'll just they are like holes, I'll just put 2 wires there, like the red one, the last middle red one, sorry, the middle red one, I'll pin it there, and 1 wire white one in the neutral or gray or green, whatever wire, minus wire, like this, so I can get 2 currents out of it. Now basically what I'll do, I'll just put the red wire or positive wire in the positive side, like you can see this is the positive side, and this wire on the negative side. If you can see, like if you can see my breadboard, let me just hook up a little bit. So what I have done, basically I have connected positive motor positive to battery positive and motor negative to battery negative in the same lane. Now let me just uh, pick the Raspberry Pi, and just you have to pin like on the ground wire here, and pin that ground wire on the minus sign of your Raspberry Pi on the breadboard, sorry. So basically it's on my breadboard on the minus line or neutral line. Now for the, this is the for controlling wire. Okay, I'll need one more. Yeah, so now I'll just yellow wire, or you can see the yellow wire last for the controlling wire like this. I'll just hook up it here on a normal, like where it touches nowhere, and I'll just put some, you can see, if you can see now, I'll just put some, yeah, sorry, let me have some space here, make them whole. Just wait, let me just connect. Yeah, so I have put the controlling wire here and the resistor with the on the other side. And now on the Raspberry Pi, what I'll do, I'll pin it on the pin number 17, or whatever pin you like to work on. Like pin number 17 is the sixth pin from here. Like if I can show you clearly, let me just unplug it. Yeah, so basically the sixth pin is 1 2 3 4 5 6. Let me just pin it there. 1 2 3 4 5 6. Sixth pin is the pin number 17, GPIO pin number 17. Let me count it again. 1 2 3 4 5 6. And the wire I have removed is the ground pin here, third. 1 2 3, third pin from here. You can see it now. I think it's clearly visible to you. So let's just go on to the coding part. Sorry, I forgot one thing, like the one you have plugged in the pin number 17 or the sixth pin from here, you have to pin this pin just after, just next to like your resistor. So make the connection with the control wire. You can see that this goes here and here, and this comes to yellow wire in the motor. Okay, so yeah. Okay guys, I'm not let you know how you can code for this. Basically I have put on a white paper background because uh, behind that was also black, so maybe it was not visible my motor. So let me just show how you will code. You'll just like this, from Gpio 0 import. You don't have to install any package or something, everything is pre-installed. From GPI 0 import servo, from time import sleep. We'll just make it sleep afterwards, like on every round, so that's why. Pin we are gonna use 17, so we are letting GP go 17. You can use any pin of your choice. So we'll say servo equal to servo, and we'll say GP, like GP is our pin number 17. You can directly write 17, and we say while true servo dot min, and we'll say sleep. We'll sleep for 1 second to let the motor rest, or whatever the reason. Servo dot mid. You can just play around with the code afterwards, like after when I will show you like how it will work. You can just play with code, how you can make more amazing things. Max Yeah, so now let me just run the code and just see what happens on that side, motor side. You can see it, I think, how the code is working so beautifully. Ah, see, so beautiful. So yeah, that was it, and this is the code. You can just write it and just like delete servo.mains and servo.max or servo.mid, whatever you feel like and whatever you need is. So that was it. Yeah, and mine was 180-degree, and you can have whatever of your choice. So yeah, thank you. Okay guys, today we're gonna learn like how you can do face detection on Raspberry Pi with the help of Pi camera. So let me just show you the demo, like how will it look like. Okay, let me just tell you the like basic difference between face recognition and face detection. Face detection is basically like detecting your face, and face recognition is basically like recognizing who you are basically. So that's the difference. So you will need some libraries to install, like you need Opencv Python. You can just Google it like how to install Opencv Python on Raspberry Pi, and one more library like face recognition. You can just like Google it like how to install OpenCV on Raspberry Pi and how to install face recognition on Raspberry Pi 4 or Raspbian. So just follow the tutorial or something like documents, so you can just easily install both libraries. Like just like Python. Yeah, you will need this library. And see, we'll be using like the Pi camera. You can use USB camera also, but the Pi camera is very fast, as I have seen in other things that like Pi camera directly runs on the GPU as mentioned on some documents. So you can do it directly. So yeah, so you can like your Pi camera should be connected. You can check how it's connected or not. That I'm just gonna let you how to code. Okay, so let's get started. So we'll do import. Let me just make it some bigger. Yeah, import Pi camera, import Pi camera dot array, import face recognition, import cv2. So these are the imports we are using like libraries. Now we'll do with Pi camera dot Pi camera, yeah, as camera. So yeah, basically we are opening the Pi camera, and now we'll use it in the form of array. So we'll do Pi camera dot array dot pi will open in the form of RGB array. Yeah, camera as string. Just basically write what I'm writing. It will work like this only. And it's a fast way of working with Pi cameras. I have seen multiple codes and documents. I have found like this one works very fast. This like coding stuff like what I'm doing. Now we'll just change the resolution. You can just pick any resolution, but I think it's supposed only like 600 into 400. So yeah, you can just check it, but yeah, basically people use like 600 by 400 like resolution only. When we do see, this is optional. Camera dot v flip, vertical flip, like Raspberry Pi camera is basically like this, or like it's, let me just show you. Oh, it's very suffocated and So is V flip like it's sometime image shows upside down. So you can just check it. If your image of video is upside down, you can just make V flip true. Otherwise, let it be false. But basically, in most cases, you have to make it true. As I have. So now we'll just start the OpenCV coding file true. We just yeah while true. Now we are starting with the OpenCV. Like this is the like this part. We have opened the camera and started the using camera. Now we'll just start with the main part. Now we'll do camera dot capture stream bgr. Just telling you in a minute what we are doing. Use video for. See, we are capturing the like open OpenCV work on frames, so we are just capturing again and again the pic from the like whatever camera is streaming, and we are taking it in BGR form. Like OpenCV works in BGR form, but normally everything works in RGB, so we are taking BGR format and use video port. I just don't know, like it was there in the documentation, maybe something. Now we'll do frame is equal to cv2 dot we'll like resizing it to 1/4 because we want to like if the size of the image will be 1/4, so it will do the processing fast. So basically that's why we are resizing it to 1/4. Stream.array is the image name, like the image is coming, like what we use frame in OpenCV. In this we use stream.array, like coming in the form of array. Stream.array is the image. Now we'll do like 0 comma 0 none 0.25. So basically we are just scaling down the image. Now we'll do frame cv2 dot convert color. I'm telling you why we are like converting the color of frame frame comma cv2 dot the color cv2 dot color score. Like we are converting from BGR format to RGB because like face recognition library use RGB format. So yeah, we are basically doing that. Now we'll like if face no, I will write this line in the end. Now we'll do like we'll just take the y1 comma x2 comma y2 comma x1 is equal to face recognition dot face locations comma frame. So we are just like running this and we are taking the face location, like face location like gives us 4 different values like 1 2 3 4. So we can just put a like a square or rectangle, whatever you want, and we'll do like here is 0 because face location returns us an array sorry list. In that list, if you have two faces, so it will just return two faces of list. So inside this you have a set, so we are just taking like the first one. So basically you will just print it and so we are taking the first one, and now we'll do now our work is done. Now what we'll do, like y1, like we just copy it and we'll just increase it 4 times. Like it was scaled down here, now we have to put on the real image, so we have to like increase it by 4 times into 4. just make it into 4. Yeah, like we have done it like into 4. Now we'll just put rectangle cv2 dot rectangle. We'll put a rectangle there on that locations, and the main file is stream dot array, and location is x1 comma y1. You just put a comma here, x2 comma y2, and we'll just pick any color like 255 0 comma whatever color you need, and thickness like 2, the thickness of it. And now this, like, you can just get any face, like if you want to print anything behind them like name or something, you'll just, oh sorry, copy it and just like paste it here and like write, put text, and here like whatever name you want to give, name name, and we like do the like -6, and we'll here put like y2 plus 6, because we like build the x and y, and here we'll put like on the chin the name, so like that's why we are doing that. And we'll just clear it, and the font we want cv2 dot font or font, whatever you call it, her like whatever style you want, you have like multiple, and the thickness of it like 1, not thickness, sorry, thickness is 2, like 1, I just forgot what is 1, just write it. So yeah, so we are basically done. Now we'll just do cv2 dot im show, and whatever want to show, like we want to show stream dot array, and and what is the value, stream dot array, yeah. Or you can just, the window name you can just write is like video, whatever you love it. And for closing we just like for closing we like if cv2 dot wait key, like to close it, wait key 1 and 0 xff, like whenever we like print sorry, press q, so the video will just exit. We'll just do break, always exit like doing the q only, because I remember like the last time my cam was open, like it wasn't closing, like I'm opening my camera again and releasing it, but it wasn't like closing, it was open forever. I have to do a software install and install multiple times and started working normally. Now we'll do stream dot seek. We'll just now here we'll have to like extra code, like we don't generally light in what do you say, in normal camera, because here we are just refreshing it again. So yeah, that's the only way like we have to do it. And now we'll use cv2 dot destroy all windows. Okay, so like this is the whole code, you have to just run it and it will just work very fine. See, one problem may occur, if you see like here, this line, like if like y1 x2 phase equation, and we are getting the first phase asset, we are getting the first phase from the list. So suppose there isn't a face, like camera is open but you are not in front of it, so like it will just throw an error, because it will go and check and it will say okay, there isn't any image. sorry, any people. So how do I get the face location? So it will throw an error. So what you can do, you can just write it like if, and just copy the same line, control C. Yeah, so yeah, you just write it like if the face is visible, like it will go, let me just do it. Yeah, it will just go here, like check, okay, the face is visible or not, and it will check if the face is visible. So it will just come down and do the other stuff. If the face is invisible, it will just show you directly. So yeah, that's the whole thing you want to do, and that's up from my side. If you want to do any code or something, you can just comment it. I will just provide you. And one thing more, like try installing it with like uh, yeah, whatever the way you find installing face recognition or Opencv on Raspberry Pi. Once installed, everything will just work fine. Okay, that's from my side. Thank you.